Hello, folks. Welcome to your second section of our last chapter of the school year. I think I'm going to remind you about that for every video for this chapter because that's just super exciting. Main difference between today's video and yesterday's concept was that these sequences and series are called geometric, whereas yesterday those were called arithmetic. And basically, you're going to notice, like I'm going to write an example here. It's still numbers and patterns and stuff like that, but with these numbers, like if I give you, let's start with 1, and then 1/3, and then 1/9, and if I say, okay, what are the next 3 terms? Basically, with your arithmetic sequences, you have a common difference between your terms, right? You add 3 or you subtract 5 or whatever. With geometric sequences and series, you figure out what number are you multiplying by to get from one to the other, right? So 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. So basically, the idea here is that if you multiply each of your terms by 1/3, you get to the next one. So 1/9 times 1/3 is 1/27. 1/27 times 1/3 is 1/81. And 1/81 times 1/3 is 1/243. And of course, we could continue this if we wanted. So, by definition, a geometric sequence is a sequence in which, and you can feel free to shorthand this definition if you'd like, is a sequence in which each term after the first term, and as we talked about yesterday, your first term is denoted by a sub 1, is the product, and that's the main difference between geometric and arithmetic. It's the product of the preceding term, and instead of a common difference, right? In arithmetic sequences have a common difference. Geometric sequences have a common ratio, and that's denoted by R. So common difference is denoted by D, common ratio is denoted by R. So geometric sequences look like this. First term is a sub 1. To get to the second term, and it's exactly like what we did up here, you take your first term, a sub 1, and you multiply it times R. Then, again, this is a sub 2, so you could take a sub 2 times R, but ideally what's going on here is, and this is what we're going to get to in just a second, I'm going to ask, hey, what is the 100th term in the sequence? You're not going to write them all out. So the idea is to write each term by way of your first term times your ratio to the next power. So your first term is like a1 times r to the 0 power. Second term is r to the first. Third term is r to the second. Fourth term would be a1 times r cubed. And then this will continue. So to find r, and this is in very, very unmathematically perfect defined methods here. To find r, your common ratio, essentially you take any term that you want and you divide it by the term before it. So in order to find your ratio, what number was multiplied, then you just divide 2 of your terms. But you put one term divided by the term before it. You don't divide the first term by the second term. So let's do an example. I'm going to give you 4, 12, and 36. And very simple, I want you to find the next 3 numbers. So if I ask you, because some of your homework is going to ask you for the common ratio and then the next 3 numbers. So again, in order to get your common ratio, you just need to divide any 2 numbers, but the order is you divide one number divided by the term before it. So if I want to get the common ratio, you either have to do 12 divided by 4 or 36 divided by 12. Either way, you get that the common ratio is 3. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. And 324 times 3 is 972. So very, very simple. Now, if I ask you for some, absurd number, like what is the 300th term in this sequence? That can also be, let me change colors here since this is a definition. That could be considered how to find the nth term. How to find the nth term of a geometric sequence. And that's given by the formula. A sub n is equal to a sub 1 times r, and you could kind of figure out the pattern here. I said the second term is r to the first power, the third term is r to the second, the fourth term is r to the third. So these exponents are one less than the term that this is. So it'd be a sub 1 times r to the n minus 1 power. So this is the first big takeaway from today's video. First formula. The nth term, a sub 1, is our first term. So in order to find any nth term, and then r, of course, is the common ratio. So let's do an example. I want you to find the 7th term. Find the 7th term of the geometric sequence. So 157, negative 47.1, 14.13, and then it continues. So if I want to know the 7th term, I'm going to use this equation up here. And in order to do that, I have to know, I already know a sub 1, I know the first term. The only other thing that I need to find is r, I need the common ratio. So again, to find that common ratio, you just divide any number, any term, by the term before it. So I'm going to divide negative 47.1 divided by 157. And again, it would have worked had you done 14.13 divided by negative 47.1. Either way, you'll get that the common ratio is negative 0.3. So then if we take that value and substitute that into the equation for the nth term, in this case, we're looking for the 7th term. So a sub 7 is going to equal a sub 1 is our first term, which is 157, times the ratio, negative 0.3. It's important that you put this in parentheses, by the way, because you're raising only r to that power. And then n minus 1, again, n is 7. So it'll be 7 minus 1, essentially negative 0.3 to the 6th power. I say it's important to put that in parentheses because when you do negative 0.3 to the 6th power, you're going to end up with a positive number. Specifically, you'll get the 7th term is, let's just write the whole thing. It's a relatively long decimal, but not anything we can't write. 0.114453 would be the 7th term. And you can follow suit with the given terms here. Like since these were in decimals, your 7th term should be a decimal. The first example that we did earlier was all in fraction form, so you need to continue the pattern in fraction form. That's kind of the rule of thumb, is going off of what was already given to us. Okay, now recall when we talked about this yesterday, the term geometric means just stood for terms that were between any two non-consecutive terms. So like negative 47.1 was the geometric mean between 157 and 14.13. It's the same for these geometric series as it was with the arithmetic means. It's just the terms between it. So I might ask you a question like this. Form a sequence with two geometric means. And again, geometric is important because that's telling us the type of the sequence that we're talking about. Between 128 and 54. 128 and 54. So basically what's going on is we have our first term, which is 128. There are two geometric means between the numbers. So we're going to have two spaces, and then we're going to have the number 54. So our job is just to figure out the numbers in between. In order to do that, if I know what the common ratio is, if I know what R is, then I could use that common ratio, multiply by 128, and find these middle two terms. So again, we're going to use this formula for the nth term. Let me use red. So that's going to be A sub n is equal to A sub 1 times R to the n minus 1. And for this particular sequence, I'm going to have 4 terms. So n is going to be 4. So if I have A sub 4 will equal A sub 1, which I know that first term, but I'm just going to leave it there for a second, times R to the, again, 4 minus 1 power. And then if I substitute in what I know my fourth term is 54. So it'll be 54 equals A sub 1. I know the first term is 128 times R to the 4 minus 1 is 3, so R cubed. So the goal to solve for R, I need to isolate my R cubed term. So I'm going to divide both sides by 128. So 54 divided by 128. You could write this as a decimal, but I converted mine to a fraction. I just think it's a little bit easier to work in fractions. I get 27 over 64 is equal to R cubed. And the reason for doing that is I recognize both of these are cubed numbers, so that when I go ahead and take the cubed root of both sides, right? Cubed root is the inverse of cubing a number. So when I take the cubed root of both sides, I get that R is equal to 0.75, or in that case, 3 over 4. So meaning I need to take 128 times 0.75, or times 3/4, which would be 96. 96 times 0.75 is 72. And then I always like to check and make sure I end up at the right spot. If I multiply by 0.75 again, I get down to 54, which lets me know that I have the correct common ratio. So that's how to come up with a sequence with, X number of geometric means. Okay, that's all of the sequences. The next thing, the last thing to discuss is the series. And very similar to the arithmetic sequence versus series, a geometric series is simply the sum of the terms of a geometric sequence. Very simple. Sequence. Geometric series is the sum of the terms of a geometric sequence. So the geometric sequence is still done by the common ratio that you multiply, but instead of just listing out those numbers, you add those numbers together. So for example, I could give you a sequence of 1, 4, 16, 64, 256, and the corresponding series would be 1 plus 4 plus 16 plus 64 plus 256. And this is enough for the series. You don't have to add them together, but if I actually wanted to add them together, then it would have a sum of 341. So it's just very simple. Sequence, geometric sequence. Its common ratio would be 4, right? 1 times 4 is 4, 4 times 4 is 16, times 4 is 64, etc. The series is just adding those numbers together. So similar to finding the nth term of a sequence, if I ask you for a crazy amount, like add the first 50 terms of this series, we have a formula to do that without stressing out too much. And it's given by this. So the sum of a geometric series is denoted by, and we have two forms, and it doesn't matter which one you prefer. S sub n is equal to sum, S standing for sum of n stands for the number of terms in your series. A sub 1 minus A sub 1 times r to the n power all over 1 minus r. And I'm putting 1 minus r in parentheses here because when you type this into your calculator, you have to be very sure to also put that number in parentheses, or just make sure you simplify it before you plug it in. In this case, r cannot equal 1. If it equals 1, then you'd have 0 in the denominator, which we are not allowed to divide by 0. So you can use this formula, or you can use this formula. S sub n is equal to, this formula is just a rewriting of this one. If you factor out a sub 1 in the numerator, then you would be left with, in parentheses, 1 minus r to the n power all over 1 minus r, and again, r just cannot be 1. So here's the second big takeaway. The sum of a geometric series. And like I said, it does not matter which one of these equations you use. They are literally equivalent. It just kind of depends on, I prefer the second one for some reason, but you can use either and you should still get the same answer. So if we do an example, find the sum of the first 6 terms of the following series. 2 minus 6 plus 18 minus 54 plus ... Now, a couple things. If you saw this on a homework or a test or anything, and I wanted to know just the first 6 terms, you could use your logic. Find your common ratio. I give you the first 4 terms already, so figure out what the common ratio is. Just keep using it to find 2 more terms, and then add them up all together. Okay, but for the sake of practicing the formulas, we are going to use one of them. So either formula you choose, you have to know a sub 1, which is your first term, which we know that. We know that a sub 1 is 2. So let's write on our information. We know our first term is 2. N stands for however many terms are in your series. In this case, n is equal to 6. And then the only other thing that we need to find is r, your common ratio. Well, again, to get your common ratio, you just need to take any term and divide it by the term before it. So I'm just going to do my first 2 terms. I'm going to take negative 6 divided by 2, which is negative 3. So 2 times negative 3 is negative 6. Negative 6 times negative 3 is 18. Times negative 3 is negative 54. So you'll notice, because my common ratio is a negative, every other term has a different sign, positive and negative. So r is equal to negative 3. So now I'm going to take these variables and substitute them into either one of my geometric series sum equations. I'm going to use the second one. S sub n, in this case n, I have 6 terms, is equal to a sub 1, the first term we already established is 2, open parentheses, 1 minus r is negative. Anytime your rate is negative, your common ratio is negative, you've got to make sure to put it in parentheses. So 1 minus negative 3 to the n power, again n is 6, and then close parentheses. All divided by 1 minus r, so that'll be 1 minus negative 3. And then your goal is just to simplify this. Again, just be very careful. Make sure you take order of operations into account. This will be 2 times. Inside these parentheses, you have to do the exponent first. So that'll be 1 minus negative 3 to the 6th power. Negative 3 to the 6th power is going to be a positive 729. Positive 729. All divided by 1 minus negative 3 is positive 4, which is going to be 2 times negative 728, all divided by 4, which is going to be negative 1456 divided by 4, which is going to be a negative 364 is the sum of the first 6 terms. And again, I gave you the first 4 terms. You could easily find the next 2 terms by multiplying by negative 3 by -3 and then add those up together. But this is just practice using the actual sum of geometric series formulas. Again, I want to remind you the corresponding homework that goes along with this is paired with 12.1. You can find it at the end of yesterday's video, or I'm sure it's up on the board in class as well. Your odd answers are in the back of the book. Most of the time there's work to be shown. Mr. Ware has answers to the evens in his textbook for you to check those as well. This homework is due on Friday when you walk into class. Good luck. Email if you have any questions.